Good morning, everyone. In today's session, we will be discussing normal random variable and normal distribution. We call a random variable x, normal random variable or Gaussian random variable if the probability density function of x is of the form f of x equal to 1 by sigma root of 2 pi e raised to minus 1 by 2 x minus mu by sigma the whole square, where x is varying from minus infinity to infinity. We also say that x has a normal distribution. Now, if the mean mu is equal to 0 and sigma is equal to 1, if mu equal to 0 and sigma equal to 1, we call the variable standard normal or normalized Gaussian variable, and is denoted by z. So it is of the form 1 by root of 2 pi e raised to minus 1 by 2 z square, where z is also varying from 0 to infinity. Now let's talk about expectation and variance of a normal random variable. If x is a normal random variable with parameters mean mu and variance sigma square, then expectation of x or mean of the normal random variable is the parameter mu and variance is sigma square. Now let's see how to get this. For that, we are calculating expectation of x minus mu, that is minus infinity to infinity x minus mu times the probability density function, which is given by 1 by sigma root 2 pi e raised to minus 1 by 2 x minus mu by sigma the whole square. Now it is x minus mu by sigma 1 by root of 2 pi e raised to minus 1 by 2 x minus mu by sigma the whole square. Now if we call e raised to x minus mu by sigma to be z, x minus mu by sigma to be z, then we can replace x minus mu by sigma by z and we will be getting z times 1 by root of 2 pi e raised to minus 1 by 2 z square, and dx will be replaced with sigma times dz. That's why we are having an extra sigma here. Now minus infinity to infinity z times e raised to minus 1 by 2 z square. This is an odd function, hence the integral is equal to 0, and we are getting expectation of x minus mu is equal to 0, hence expectation of x minus expectation of mu is equal to 0, or expectation of x is equal to expectation of mu, which is simple mu. Now let's compute variance of x. We will get expectation of x minus mu the whole square. We will get x integral minus infinity to infinity x minus mu the whole square times f of x dx, where f of x is 1 by sigma root of 2 pi e raised to minus 1 by 2 x minus mu by sigma the whole square. Now the same way we can substitute x minus mu by sigma to be z, and hence you will get sigma dz to be dx. You will get sigma square by root of 2 pi integral from minus infinity to infinity z square e raised to minus 1 by 2 z square. Now applying by parts, we will get it of the form sigma square by root of 2 pi as it is z times e raised to minus 1 by 2 the whole e raised to minus 1 by 2 minus integral of derivative of first, integral of second is minus e raised to minus z square by 2. Now this integral is equal to 0 because this is an z times e minus e raised to minus z square by 2. When you apply infinity and minus infinity, you will get it 0 because e raised to minus infinity is 0. Now the integral, we have sigma square times, so the first term we are getting 0 plus sigma square by root of 2 pi integral minus infinity to infinity e raised to minus z square by 2, which is sigma square times integral minus infinity to infinity phi of z dz, which is equal to 1, because we have phi of z was the probability density function of the variable z, where z is the standard normal variable. Hence the total probability minus infinity to infinity phi of z is equal to 1. Hence you are getting variance of x to be equal to sigma square. Now, in order to find the probability between a and b, we have integral from a to b f of x dx, where f of x is 1 by sigma root of 2 pi raised to minus 1 by 2 x minus mu by sigma the whole square. But it is tedious to evaluate this particular integral. So what we are going to do is we are going to convert it in terms of the new variable, standard normal variable z, where z is x minus mu by sigma. So if you have to evaluate probability that x is between a and b, which is same as probability between a minus mu by sigma, which is less than x minus mu by sigma, which is less than b minus mu by sigma. Now x minus mu by sigma is z. That's why we are having the result probability that x between a and b is same as probability of z between a minus mu by sigma and b minus mu by sigma. Now we can see that the graph of the standard normal variable, the probability density graph, is symmetric with respect to y-axis. So we have the properties. The first property is probability that z greater than 0 is same as probability that z less than or equal to 0, which is same as 0.5. We know that the total probability or area under the graph is 1, and it is equally distributed between the left side and right hand side of the y-axis. Now the second property is also due to the symmetry, probability that 0 less than z less than a is same as probability that minus a less than z less than 0. That is this area. Probability that minus a to 0 probability is same as probability that z is between 0 to a. Probability between 0 to a. Now, in order to get probability of z less than minus a, we know that the total probability is 0.5. In order to get the probability of z less than minus a, we know the total probability of the left hand side is 0.5. So 0.5 minus probability of z minus a to 0, z between minus a to 0. And due to the symmetry, this is 0.5 minus probability of 0 less than z less than a. Now, if you have a random variable, to read these values, we have a standard normal table, which I will show you now. This is the standard normal table. Now, let's see how to read this table. So, let's do one problem and see how to read this table. Suppose if you have x to be a normal random variable with mean equal to -3 and variance 4, find probability that x is between 1 and 2, probability of x greater than -1.5, probability of x less than -3, probability of mod x plus 3 less than 2, and probability of mod x plus 5 greater than 1. So let's start with the first one. Probability of x between 1 and 2. Probability of x between 1 and 2. Let's convert the variable x to z. You will get 1 minus mu. Mu is -3 divided by variance sigma square is 4. So sigma is 2 is less than or equal to x minus mu by sigma is the variable z, which is less than or equal to 2 minus -3 divided by 2. So this is same as probability between 2 and 2.5. Now let's see how to read this. Let's see how to read this step. So we want to find the probability between where z is between 2 and 2.5. Now you can see that the shaded portion area is representing probability that 0 less than z less than or equal to small z, where z is this particular value. So the shaded portion area is giving you the probability that z, the variable, is taking a value between 0 and z. Now in order to, so from the table we can only find the value of the probability where z is between 0 and a particular number. Now how can we rewrite the probability that z is between 2 and 2.5 in terms of 0 to a particular number? Now let's see how it is possible. So I'm taking the probability of z between 0 to 2.5 minus probability of z between 0 to 2. That means your 2 is here, 2.5 is here. Our required area is this one. So what we are going to do is we are first finding the total area till 2.5, and then deleting the area till 2. So in order to get the area between 2 and 2.5, first we are finding the total area till 2.5 and then deleting the smaller area till 2. Now how to find this value, probability value, from the table? Probability that z is between 0 and 2.5. So let's see how is it. You can see that z value, the rows are representing the z values and the columns are representing the second decimal place of the z value. So 2.5. 2.5 means if you take it to up to 2 decimal places, you can see that 2.5 means 2.50. Now let's take the row corresponding to 2.5. The row corresponding to 2.5. So this is the row corresponding to 2.5. Now 2.50 means you are taking 0.00, the first column. If it was 2.51, we will select the second column. If it was 2.52, we will select the third column, so and so. Now we are having 2.50, so we are selecting the value corresponding to the row 2.5 and the column, first column, corresponding to 0.00. So you can see that the value is 0.4938. That is the probability that 0 less than or equal to z less than or equal to 2.5 minus probability that z is between 0 and 2. Again 2 can be represented by 2.00. So select the row corresponding to 2.0, and 0.00 is the first column and the value is 0.4772. 0.4772. Hence, the answer will be 0.0166 around. So this is the probability that Z is between 2 and 2.5, or probability that X is between 1 and 3. Probability that X is between 1 and 2. Probability that X is between 1 and 2. Similarly, now let's find the probability that X is greater than 1.5. Probability that X is greater than 1.5. X greater than 1.5. So the first step is convert the variable x to standard normal variable z by replacing x by x minus mu by sigma, that is z is greater than 1.5 minus mu is minus 3 divided by sigma is, what was sigma? With mean minus 3 and variance 4, so sigma is 2. Sorry, x was greater than minus 1.5. So minus 1.5 minus of minus 3 divided by 2. So probability of x greater than minus 1.5 is same as probability that the standard variable z is greater than minus 1.5 plus 3 by 2, and that is probability of z greater than 0.75. So let's draw the graph first. 0.75 is somewhere here. 0.7 z greater than 0.75 means the values on to the right hand side of 0.75, and probability is the area of the shaded region. Now how to find this? So in order to find this, we know that the total right hand side area is 0.5 minus, we are deleting the probability or the area from 0 to 0.75. 0 to 0.75. Now this is 0.5 minus. Now to get the value of 0.75, we are selecting the column corresponding to 0.7 and the column corresponding to 0.05, because 0.75 can be written as 0.75 plus 0.7 plus 0.05. So let's see how it is. 0.7. 0.75. So 0.75 is here and the value is 0.2734. So 0.2734. 0.5 minus 0.2734 is the probability that x greater than minus 1.5. Now the third part, probability that x less than minus 3. Probability that x less than minus 3. Probability that x less than minus 3. Which is same as probability that z less than minus 3 minus 3 divided by 2, which is equal to probability that z is less than 0. And the value will be 0.5, because the total area z less than 0 means you are having the total left hand side, and the total left hand side area is 0.5. We can write it directly. Now let's move to the fourth part of the question, which is probability of mod of x plus 3 less than 2. Probability of mod of x plus 3 less than 2, which is equal to probability that minus 2 less than x plus 3 less than 2. Now z is equal to x minus minus 3 divided by 2, that is x plus 3 by 2. We have x plus 3 already, so just divide by 2. Probability of minus 2 by 2 less than x plus 3 divided by 2 less than 2 by 2. throughout by 2. Dividing throughout by 2, you will get probability of -1 less than x plus 3 by 2 is the variable z, which is the standard normal variable, less than 1. Now I can write it as 2 times, I can write it as 2 times probability that 0 less than z less than 1, because -1 to probability that -1 to 0 area is same as probability that z is between 0 and 1. Probability between -1 and 0 is same as probability between 0 and 1. That's why we are taking 2 times probability that z is between 0 and 1, and the value you will get it from the table corresponding to 1.00. 1.0 and the first column, and the answer is 2 times 0.3413. Now, moving to the last part, probability that mod of x plus 5 is greater than 1. Probability that mod of x plus 5, probability that mod of x plus 5 greater than 1. So I can write it as 1 minus probability of mod of x plus 5 less than 1. Because x plus 5 greater than 1, the opposite is x plus 5 less than 1, and we know that the total probability is 1. That's why we are taking 1 minus probability of x plus 5 less than 1, less than or equal to 1, which means that 1 minus probability that -1 less than or equal to x plus 5 less than or equal to 1. Now, to write x in terms of z, we have z equal to x plus 3 divided by 2, 1 minus probability that -1 to get 3, we are subtracting by 2. 1 minus 1 divided by 2 less than or equal to x plus 5 minus 2 divided by 2 less than or equal to 1 minus 2 divided by 2. Which is same as 1 minus probability of 3 minus 3 divided by 2 is minus 1.5 less than or equal to x plus 3 by 2 is the variable z, which is less than or equal to minus 1 divided by 2, that is minus 0.5. So this is 1 minus probability between minus 1.5 and 0.5 is same as probability between 0.5 and 1.5 due to the symmetry. Due to the symmetry, the probability between minus 1.5, the area between minus 1.5 and minus 0.5, the area between minus 1.5 and 0.5 is same as the area between 0.5 and 1.5 due to the symmetry of the standard normal curve. Now, again using the property which we already use, 1 minus, I can write it as probability of 0 less than or equal to z less than or equal to 1.5 minus probability that is 0 less than or equal to z less than or equal to 0.5. Now let's read the value of 1.5. You will get 1 minus 1.5 value is 1.5 value is 0.4332, 0.4332 minus 0.5 value is 0.5 value is 0.1915. 0.1915. So this is the probability that mod of x plus 5 is greater than 1. I hope everyone understood how to read the table of the normal curve or normal distribution. Thank you.